Good evening, everyone. Am I audible? Okay. So, myself, Anjali Ramashankar Prasad. Currently, I am pursuing PhD in mathematics from IIT ISM Dhanbad, and I am a PMRF scholar. So, today I am going to start with the course discussion of numerical methods NOC23-ma11. Okay, so hope you have all started with the video lectures from week 1, week 2 also. So you have been allotted some assignments of week 1, week 0 also. So here today we are going to start with the discussion for some sample questions which will help you to solve questions from week 1 assignment. Okay, so uh, let's wait for few more minutes, then we will start with our discussion session. So let's start with the session. Is my presentation visible? Can anyone confirm? Okay. So let's start with our discussion. So today we are going to start our week 1 assignment sample questions. So our topic is numerical methods finite difference approach, and it has been already discussed with by Professor Amir Kumar Naik. He's from IIT Roorkee, and myself Anjali Ramashankar Prasad. I am PMRF scholar, and I am in IIT ISM Dhanbad. Okay, so let's start with our discussion. So here comes our first question. So if you have been given a ordinary differential equation, so your question is, you have a ordinary differential equation dy by dt is equals to minus 2ty square with y of 0 is equals to 1 in the interval 0 comma 1. Okay, so if the question is, while solving this ODE by Runge-Kutta method of order 4, what should be the value of y at 0.2? Okay, so here as we are starting from 0 to 1, our range is from 0 to 1, so our initial value will be 0. So here x naught is what? X naught is 0 and y naught is equals to 1. Okay, so now you have to take h is equals to 0.2 and you have to calculate the value at y of 0.2. Okay, so start your solution by using Runge-Kutta method of order 4. So you might be knowing the formula for Runge-Kutta method of order 4. So what's the formula? It's given by y anyone? Okay, so y is equals to 1 by 6 times k1 plus 2k2 plus 2k3 plus k4. Okay, where k1, k2, k3 and k4 are also need to be calculated. So please proceed with the formula and calculate the y at 0.2. So what's the formula? Y at n plus 1 is equals to 1 by 6 times k1 plus 2k2 plus 2k3 plus k4. So anybody got the values of k1, k2, k3 and k4? So here what will be the value of k? How we will calculate k1? It can be simply calculated as h times, sorry, h times f of x naught comma y naught. Just put the value of x naught and y naught in the given function f of xy, that is minus 2ty square. Sorry, here it will be, we have the function in the form of t. So take here t naught. So simply put your values, you will get the k1, k2, k3 and k4. So here is our answer. So you will get the values like this. Yn plus 1 is equals to what? Yn plus 1 by 6 k1 plus 2k2 plus 2k3 plus k4. Okay. So where k1 is given by h of f of xn comma yn. So here when you will put the values of x0 and y0, you will get k1, similarly k2, k3 and k4. Okay. Then after calculating, you will get approximate solution as near to 0.96. Hope you are all solving along with me. Okay, so let's proceed to our next question. So second question is, pick the correct option when using Euler method for solving dy by dt is equals to minus ty square on the interval 2 to 3 with y of 2 is equals to 1 and h is equals to 0.1. Okay, so here basically you have been given dy by dt is equals to function as minus t into y square. You have to use Euler method and you have to calculate the value of y of 2.3. Okay, and for calculating y of 2.3 you have to take increments, like first increment will be 0.1 and then h you increase for next iteration, so y of 2.2 you will get, as you are starting from 2, so first iteration you will get 2.1, then you will get 2.2, then you will get 2.3. Okay, so proceed in this manner. So here what we have been given as f of t comma y is equals to minus t into y square. Okay, so this is our f of t comma y. Now your y naught value is what? 1, and x naught is given as 2. Okay, sorry, t naught. T naught is given as 2. So just put these values in Euler's formula. You will get your first increment, that is y of 2.1. Calculate it. What is the Euler's formula? So for calculating yn plus 1, okay, so first you have to calculate what? y1. So y1 is given by y naught plus h times f of t naught comma y naught. Just put the values and you will get the value of y1. Okay, so you will get y1 as 0.8 something. Now calculate y2. Similarly y0 plus h times f of t1 comma y1. Okay, sorry, here it will be y1. y1 plus h into f of t1 comma y1. Just put the values, you will get the value of y of y2. Here you might have get the value of y of 2.1. Here y of 2.2 you will get. Similarly, if you will proceed, you will get y of 2.3. Okay, just calculate it and we'll get the solution. Hello, am I audible? So anyone got the answer of second question? So sorry for the interruption. So here, as you can see, the Euler method formula is what? Yn plus 1 is equals to yn plus h times f of xn comma yn. So when you'll put for first iteration, so when you put n is equals to 0, so here you will get y1 is equals to y0 plus h times f of x0 comma y0. Okay. So for first iteration you will get the value as y1 is equals to 0.8. For second iteration you will get 0.6656, and for third iteration you will get 0.5681. So this third iteration is what? The value we needed. Okay, so our answer is y at 2.3 is equals to 0.568. So this will be the correct answer. Okay. So this is our third question. What is the question? Pick out the value of y at y 1.5 when using modified Euler's method for solving dy by dx is equals to 2 into x into y using y of 1 is equals to 1. Here we have to calculate the value at 1.5, and what is x naught given over here? 1, and y naught is equals to what? 1. Okay, so x naught and y naught value you are having. So using modified Euler's method, you can calculate the value at y 1.5. Here h will be what? 0.1. So just put the formula of modified Euler's method, you will get the value at y of 1.5. So please proceed with the calculation. Here's our third question. Pick out the value at y of 1.5 using modified Euler's method. Okay. Here f of xy is equal to what? 2 into xy. Here x naught is given as 1 and y naught is given as 1. So just put the modified Euler's method formula. You will get the values for y of 1.5. So for this, first y1 will be what? By normal Euler's method, you will get the value of y1. So it is y naught plus h times f of x naught comma y naught. Okay. So just calculate it. You will get the value of y1. This you will get as y1 star. Okay. Now the actual y1 value will be given by what? Y naught plus h by 2 times f of x naught comma y naught plus f of x1 comma y1 star. Okay. So now here y naught will be what? 1. X naught is given as 1. So just put the value of x naught and y naught in this function 2xy. You will get the value of f of x naught y naught. Multiply with it with h, that is our 0.1. You will get the value of y1 star. So by modified Euler's method, y1 will be given by what? Y naught plus h by 2 f of x naught plus y naught plus the extra term f of x1 comma y1 star that we got over here. Just put that value. Okay. So here you'll get the answer as A, 3.4509. Hope you all got the answer. Okay, so let's proceed with our next question. So fourth question is given by, let xy by 2 into del square u by del x square minus x plus y plus 1 into del square u upon del x into del y plus xy by 2 del square u by del y square is equals to 0. So the question is, in which region should y lie so that the PDE, the given PDE is hyperbolic. Okay, so here you have to find out that region in which this given PDE will be hyperbolic. So as you know, for hyperbolic, just compare this given equation with the standard partial differential equation. Okay, that is a into del square u by del x square plus b into del square u by del x del y plus c into del square u by del y square plus e is equals to 0. Okay, so by comparing, what you'll get, a is given by xy by 2, b is what, minus x plus y plus 1, and c is xy by 2. Okay, so you have got the values of a, b and c. So for determining when the given PDE will be hyperbolic, parabolic or elliptic, you have the definitions that you have to find a discriminant, that is b square minus 4ac, and if this value is what, when this value is greater than 0, then you will get the hyperbolic PD. Means that PD will represent hyperbolic in nature. Okay, so just put the values of B, A and C and find the region in which this condition will be satisfied. Okay, so just proceed with the solution. So the first just put this values and evaluate it for greater than 0. Okay, so what's the answer you are getting? The answer will be A. Okay, how, let's see it. Okay, so after putting these values, you might have get something like this: 1 plus x plus y minus xy greater than 0. Okay, so after solving it, you'll get y greater than minus times 1 plus x upon 1 minus x. Okay, this is, you're getting one condition. Now another condition will be y plus 1 will be greater than 0. From this, both the conditions, you can calculate that y should be greater than max of this minus 1 and this minus 1 plus x upon 1 minus x. Okay, so our answer will be A. Let's proceed to the next question. Hope you are all getting the answers. Just solve it. If you are having any doubt, you can ask. Let's see the next question. So this is the next question we are having over here. Which representation is correct for del u by del t? Which representation is correct for del u by del t is equals to alpha del square u by del x square plus beta times del u by del x if we use central difference for space and forward difference for time. Okay, so you have to find which representation of among this all four options will represent this equation. Okay, so for space, that is x values del square u by del x square and del u by del x, you have to use central difference approximation, and for time value, that is del u by del t, you have to use forward difference, and you will get your answers. So please proceed with that. Hope you are all doing. So the answer is C. How you'll get? Just put the value of del u by del t. Okay, so we have to do it with forward difference. So what is the formula for forward difference? Ui n plus 1 minus ui n upon del t. Okay, that increment then is equals to alpha times del square u by del x square. So central difference approximation for this second order partial derivative with respect to x is given by ui plus 1 whole to the power n minus ui plus 1n minus 2 uin plus ui minus 1n upon delta x square. Okay, so here h square, that we denote the increment, that is delta x square plus beta times. So what is the formula for partial derivative with respect to x? ui central difference approximation, you will get it as ui plus 1 n minus ui minus 1 n upon 2 times delta x. Okay, so just shuffle the values, like delta t you multiply it over here and take ui n on the RHS and take the like terms together, you will get C. Okay, just try. If you are getting any problem, let me know.
नहीं, घर जाना पड़ता है, बहुत दूर है घर, एकदम हम लोग फिर छोटे-छोटे बच्चे भी हैं, हम लोग को देखना में दिक्कत हो जाएगी ना, फिर लेट हो जाओगे।
So next question is, which of the following does the finite difference representation represents? Okay, so here you have 2 ui plus 1 plus 3 ui minus 6 ui minus 1 plus ui minus 2 upon 6 delta x. So which of this represents this finite difference representation? So just put the values of ui plus 1 and ui minus 1 using Taylor series approximation. You will get the required answer. So proceed with that.
मतलब थोड़ा है रात को ऐसे थोड़ा है देखो, मतलब रात को ऐसे थोड़ा है तो देखो मोबाइल बेचारा जब बात होता है।
Hello. So here the Taylor series expansion of each term, you will get ui plus 1 is equals to ux plus h is equals to ux plus h times du by dx plus h square by 2 times d square u by dx square plus h cube by 6 times d cube u by dx cube plus dot dot dot. Similarly, ui minus 1. Just put this both values, ignore this higher order derivatives and evaluate. So you will get that t is equals to del u by del x. Okay. Hope you have got this answer. You del u by del x. Next question is a rectangular grid domain defined by straight lines x equals to 0, x equals to 1 and y equals to 0, y equals to 2 is discretized uniformly with grid size 0.1 cross 0.1. So you have to calculate either the total number of nodal points, what are they, or the boundary points, are they represent these values of what. So for this you can proceed like here we have given a rectangle, okay, where x is equals to 0 and x is equals to 1, then y adds 1, here it is 2. So this is our rectangle. Fine. So let's first draw the grid size at 0.1 cross 0.1. So what that means, like 0 to 0.1 you will have one line, one grid over here. Then 0.2, 0.3, in similar way till 1. Then 1.1, 1.2 till 2. Okay. Now vertically 0.1, 0.2 you will get till 1. So how many such this nodal points or boundary points in total are there? So if you will calculate over here, so how many grid points will be here, like boundary points? 10. Here it will be again 10, here 10, here 10, here 10, and here about 10. So total we get 60. So if we have to just calculate the boundary points, so how many boundary points will be there? 60. 60 boundary points will be there, but the option is 62 or 64. So both of these are incorrect. Now, so when you will calculate the inner nodal points also, so you will get approximately inside you'll get 9 cross 9, that is 81, then above 81. So in total you will get 231. Okay, so answer will be, the total number of nodal points is 231. Fine. Next question. Here you have been given 2 points, x0, y0 and x1, y1. The linear polynomial passing through the 2 points is, you have to find which of these polynomials are passing through these 2 points. Okay, so just calculate it. Next, the forward difference approximation of the mixed boundary condition del u by del x is equals to u plus beta at x is equals to xn is what amongst this? So just take the forward difference approximations of the mixed boundary conditions for del u by del x. What will be the condition? Yeah, forward. So un plus 1 comma j minus anyone? Un plus 1 comma j minus unj upon delta x is equals to, this will be what? Unj plus beta. So just take this delta x on the RHS. You will get the required solution. So you will get first one. Yeah. So when you'll put del u by del x is equals to u plus beta. So for this you just put the forward approximation. So un plus 1 comma j minus unj upon delta x will be what? Unj plus beta. Take this delta x on the RHS. And unj on RHS. So you will get this A. Okay. Just try to solve this. Are you getting A? Next, consider the PDE x plus 1 into delta square u upon del x square plus x plus y into del square u upon del x into del y plus 1 into del square u by del y square is equals to 0. So which among the following is true? So you have to, just like we have done in previous case, compare this whole PDE with the standard PDE equation. So you will get A as x plus 1, B as x plus y, and C as y plus 1. Calculate the discriminant and check for which values, either it is greater than 0 or less than 0, for finding whether it is elliptic or hyperbolic. So when you will calculate, you will get b square, that is x plus y whole square, minus 4 into a, that is x plus 1, into c, that is y plus 1. Okay, so answer is c. You will get x minus y is equals to 0 and x comma y greater than 0, so PD will represent elliptic. How? Here, as we'll calculate x plus y whole square minus 4 into a into b. So after evaluating this, you will get x minus y whole square minus 4 into x plus y plus 1. Just simplify this first term, you will get this. Okay, proceed till here. So hope you are getting this value, x minus y whole square minus 4 into x plus y plus 1. Okay, so from here you can see, if you'll put x plus y plus 1 is equals to 0, the PD will become, if this value is 0 and यार So here, last question's answer you might have got along the line x minus y equal to 0, and for x comma y greater than 0, the PDE is elliptic. Okay. Is there any doubt in this? Sorry for all the discrepancies happened today. Actually, there was lot of technical issues and network issues. So it was, I know it was very not fluent. I'll upload the presentation slide so you can go through the solutions, and hope your doubts will be cleared in the second doubt session that will be conducted tomorrow. So thanking you guys. Thank you. If you have any questions, you can ask. And sorry for all the discrepancies happened today. I'll try to overcome these problems, this network issues and technical issues. Thank you. If you have any questions, you can ask. If you have any doubt, you can ask, or related to assignment problems. I guess you don't have any doubt, so thank you for joining. You can, and sorry for all the technical issues faced today. Um, Thank you. You can leave.
हाँ मेरे को ऊपर ही कर दो मैंने आपको टाइम दिया ना कल मैं टेस्ट करके चेंज करूँगी 2 दिन से बाद में मैं प्रॉब्लम बनाऊंगी